In today's note, we're going to be looking at the sine and cosine ratios. So this is our first look at trigonometry. And basically what trigonometry is we are looking at solving for the sides and angles of triangles. Specifically, what we're going to be looking at is right angle triangles. So these cases can only work for right angle triangles. And we're going to start with the sine and cosine. We'll look at a third one in our next lesson. So the key thing that we want to know first is what our sides are in a right angle triangle. And there are certain names for them. So what we're going to do is I'm looking at a right triangle here, A, B, and C. I have an angle that's marked. So I'm going to say that this is, we'll just say angle A. So based on this angle, I need to label some sides. So the first side that I'm going to always be able to label is the side that is across from the 90 degrees, which is called the hypotenuse. So the hypotenuse, or you could just say H, and we'll just put in brackets always across from 90 degrees. So this side is always going to be across from the right angle or 90 degrees. The other sides that we have are these two other ones here, and these ones will change depending on what angle we use, but based on my angle right now, this side is going to be called my opposite. And the reason it's called the opposite is because it's across from the angle, or opposite of the angle. So across from the angle. And then my third side is the side over here, and we call that our adjacent. And it's adjacent because it is beside the angle. So beside the angle we're looking for, or that we have. So what is the sine ratio defined by? So sine ratio, these are one of our ratios again, and it is defined by the opposite, or sine of A, or the angle A, is equal to the opposite divided by the hypotenuse. Or you could think there is an acronym, it's called SOHCAHTOA. You may have heard that before. But SOH, sine is equal to opposite over hypotenuse. The cosine ratio is a little bit different. It is same idea. It's a ratio that's defined by, so cosine of an angle or of the same angle is equal to your adjacent, so the length of the adjacent side divided by the length of the hypotenuse. Or again, there is an acronym, CA, so SOHCAH, and then the next one will be TOA, but sine opposite over hypotenuse, CA, cosine is equal to adjacent over hypotenuse. So those are our ratios, and basically what these opposite, hypotenuse, and adjacent represent are just side lengths. Again, remember that this A here, this is just an angle. Same with up here. A just refers to an angle. So those are what our ratios are, and we'll look at how we can use that, or how it's used. So in example 1, use the sine or cos buttons to calculate sine A or cosine A. So I'm going to bring up the calculator on my computer here, but we want to figure out what does sine 60 equal. So if I bring up my calculator here, the way it'll work, trigonometry, sine 60. Oh. So again, every calculator is different, and I'm just learning that for this one right now. So the way this one works, I'm going to hit 60, and then if I go to my trigonometry function over here, you may have to set your calculator up as scientific if you're using a computer, or if you're using a handheld calculator, it should be there. You should see something that says something like this, sine. If you're using your phone, you may have to turn your phone to landscape, and the scientific functions will come up. One key thing, you want to make sure that it's in degrees. So on your calculator, you want to make sure it says DEG at the top. And on your phone as well, you want to make sure that the DEG button, I believe it is in the bottom left corner, is hit. So then it should say RAD, which means that it's actually in degree mode. But once that you figure that out, so we have sine, we have 60, and we want to figure out what sine 60 is. So this is our answer. Again, depending on what calculator you use, you may be able to hit the sine button first and then 60, or you may have to hit 60 first and then sine. You may want to play around with it and make sure that you do get this answer, but you should get 0. And we'll say 866. We won't worry about the rest of the decimals. So sine of 60 actually equals then 0.866. So basically it's a ratio, that's what the ratio is. We want to find out cosine of 45. So it's going to be the exact same thing. We go to we bring our calculator up. I'm going to clear it. So it was cosine of 45. So we're going to type in 45. We're going to go to our trigonometry, hit cos, and we're going to get 0.707 rounded. So cosine of 45 is equal to 0.707. In example 2, we want to do the same thing, except this is going to be a little bit different. This right here, we're going to use cosine or sine -1 or cosine -1 buttons to calculate an angle. So if we're given a ratio, or we know what the ratio or that division is, if we go back up to those formulas, what this is going to do, this is going to be for finding an angle. So if we want to find an angle and we have our division, we're going to be using this sine -1 and cosine -1. Now, just be careful, because that does not mean that it is the exponent of -1. I'll show you exactly how you can find that. But for A, if we know that sine A is equal to 0.4321, and I want to solve for A, basically what happens is, think of it as kind of the opposite operation, or canceling out. So if I get rid of the sine, it becomes sine -1 on the other side, 0.4321, and then I can solve for what A equals. So I'll show you how that looks on the calculator. So I'm going to clear everything. So 0.4321, I believe. Yep, 4321. And what we're going to do on ours, we're going to hit the trigonometry button. We're going to hit second, or the second function. So on your calculator, it may be second F, it may be shift. It will be something usually in the top left side of your calculator that lets you get to the other functions of the buttons. But here we can see sine -1, which is what we want to do. So we're going to click that, and what we get that our answer, or our angle, is 25.6. So that means that angle with that ratio is 25.6 degrees, which makes sense that this is kind of, that makes sense for an angle. If I go to the next one with cosine, again, I'm going to do cosine -1, or what I'm going to do, basically, again, I'm solving for the angle. So I'm looking for angle A. If I get rid of the cosine, it becomes cosine -1 on the other side, with my ratio, or that number that's already there, 0.5. And I'm going to do something similar to what I did before. Let me just make that degree sign smaller so we don't get it confused with the 0. So I'm going back to my calculator. I'm clearing everything. It's 0.5. I'm going back to hit the second function. So again, you have to hit the second function too, and you should get then cos -1. And when I do cos -1 of 0.5, I get that an angle of 60. So that means if I had a ratio of 0.5 between my two sides, my angle is 60 degrees. So let's go through and actually do an example of this. So we're going to determine the measure of side length x. So we have side length x over here. So the first thing we always want to do, and I'm going to write this down here. So 1, we want to label the sides. So we want to label our sides so that we know what ratio we have to use. And remember, our 3 sides are the hypotenuse, the opposite, and the adjacent. So first off, across from B, this is our hypotenuse. It's across from the right angle, so it's always there. We are given our angle down here, 60 degrees. So across from 60 degrees is our opposite, the side that's opposite the angle. So that means that the side down here has to be our adjacent, or A. Or if you don't want to get confused at the point, you can say ADJ, HYP, OPP. So how do we figure out what sine ratio to use? Well, you have your angle, you've labeled your sides. So the next step, we want to figure out what ratio. So you have to look at 2 things. 1, are we given any information for a side, and are we trying to find a side? So in this case, we're trying to find a side here, x, which is our opposite. We are also given information for our hypotenuse. So the 2 sides that we're going to be dealing with are our opposite and hypotenuse. So that tells us right there what formula or what ratio we have to use, because if we think back to the acronyms, and we only know 2 right now, SA and CA, if we have the O and the H, that means we're using sine. So I'm going to write out, so after we figure out what ratio, we know we're doing sine of an angle is equal to the opposite side length divided by the hypotenuse. So the next step, once we pick our ratio for number 3, fill in information, and solve. So we're going to fill in what information we know. We know sine, our angle is 60 degrees because that is the angle that we're given. Our opposite side we don't know, so it's x. And our hypotenuse, we do know it is 5. And now what I'm doing is I'm solving for x, or I'm solving for my missing, or my variable. And the nice thing to do, we're going to put another little pointer here. So when we say missing piece on top, so in this case our variable, our missing piece is on top, we want to bring the bottom number up and multiply. So that means this 5 is coming up to the other side, and we're going to multiply. So this becomes 5 times sine 60 equals x. And we know that sine 60, if we enter that into our calculator, because we've already done something similar to that, if we enter sine 60 into our calculator, we just get a number. So you can enter sine 60 just on the calculator alone and get a number of 0.866. So you can replace that. Or you can do it all in one step, 5 times sine 60 to get your final answer. You may find that it's slightly different because if you do sine 60, you'll see that there's a lot more decimal places than this, but I rounded it. So keep that in mind. If you are going to figure out what sine 60 is first, and you may have to depending on your calculator, try to have at least 3 decimal places. If you round it too short, you will get a different number. So when I go through and then I multiply, I should get something very close to 4.33, which is my x value. So basically what this means is that my missing side length, or x, is 4.33 centimeters. And a good way to check if this makes sense is, again, remember the hypotenuse is always the longest side of your triangle. So it makes sense that x has to be less than 5, which it is. And you can also base it on the fact that if looking at this triangle, x should be very close in length to 5 centimeters because they do look very similar, and 4.33 is very close as well. So example 4, we're going to go through those steps again. The first thing we want to do is label our sides. The first side I'm always going to label is the hypotenuse because that one's the easiest one to find. It's always across from 90 degrees. The opposite is across from my angle, and then the adjacent is the side beside my angle. And the question is asking me to solve or find the measure of side length x. So in this case, I need to know what ratio am I using. Again, look for what information is given to you. In this case, we have our angle and the sides that we need to deal with. One, we need to find the hypotenuse because that's the side that we're looking for. And we're given the value for the adjacent side. So this ratio that we have to deal with has to deal with the adjacent and hypotenuse. And if we go back up to our acronym up here at the top, we can see that the only one that has A and H is cosine, or C. So that means we have to use the cosine ratio. So cosine A is equal to, and again the formula says adjacent over hypotenuse. And now we're going to fill in our information. So cosine A is our angle, so 30 degrees, is equal to our adjacent, which is 12, divided by x, which is our unknown or our hypotenuse. Again, this one looks different than the one we just did because the missing piece is now on the bottom. So what we can do, we can make another little note here. So in this case, the missing piece on the bottom, what we're going to do is switch and divide. So what that means is I'm going to switch these two values and then divide them. So the x is going to switch with the cosine, and I don't mean just the 30, I mean the whole thing, the whole cosine 30. So x is up top, and I have 12 divided by cosine 30. So the entire thing switches. Again, I could do this step by step. I could figure out what cosine 30 is first, and you may have to. Again, it depends on your calculator, or I can do it all in one step. So 12 divided by cosine 30, I should get 13.86 as my side length. Again, if you want to check to see if this makes sense, well, the adjacent is 12 meters. The hypotenuse is the longest side, so it has to be larger than 12, and 13.86 is larger than 12. So that does make sense. In our next two examples, what we're going to do is we are going to solve for an angle. And solving for an angle is relatively easier because it's going to be the same calculation no matter what you're trying to no matter what sides you're given. It's the same idea. Whereas if we saw in the last ones, we had two different ways of solving. Either we bring it up and multiply, or we switch and divide. For finding an angle, the process is going to be the same no matter what. So in the first one, determine the measure of angle A. So angle A is right here. I'm going to put a question mark there so we know that's what we're looking for. The steps again for solving an angle, the first thing we want to do is still the same. Label the sides. So the hypotenuse is always across from the 90 degrees. The opposite, opposite is always across from your angle. So this is across from my angle. And the adjacent is beside your angle. So the next step we want to do, or we want to think about, is what ratio do we use? So in this case, what ratio do we want to use? I'm going to write the acronym for the two that we have first. So sine or cosine. And again, you want to look at, okay, I'm looking for angle A. I've labeled my sides. Which two sides do I have information for? In this case, I have my opposite and hypotenuse, so that means I have to use sine, because sine is the only one with O and H. So I'm going to use sine A is equal to opposite over hypotenuse. So the third step then is fill in the information. So for my information, I'm still going to leave it as sine A because I don't know what my angle is. I know my opposite is 6, and I know my hypotenuse is 10. If we want to continue to simplify this, we can. So we can have sine A is equal to 0.6. From here, we want to solve what A is equal to. So this is very similar to one of the calculations that we had done earlier. If I want to get A by itself, I need to get rid of the sine. And when I do that, it becomes sine -1 on the other side. And it's going to be sine -1 of 0.6. And then it's sine -1 of 0.6 is just one calculation. Remember, you may have to do shift or second function of sine to get that sine -1. Then 0.6, and when you enter that into your calculator, you should get 36.87 degrees, or you could say 37 degrees, but that is what you should get, and this would be your angle. So I guess we should fill in the fourth step. We're going to want to do the inverse of the ratio, and the inverse is referring to this sine -1 here. So this is what we mean by the inverse, where we do the sine -1. So let's try example 6. This is going to be the same idea. We're still going to follow the same steps. We still want to find the measure of angle A, so we want to look for this angle here. This is angle A. I want to first label my sides. This is the hypotenuse. The next side, because again, that's across from 90 degrees. The opposite is across from the angle, and the adjacent is beside the angle. Again, even if you have no information there, still get in the habit of labeling your sides. That way you are comfortable and familiar with it. So once I labeled my sides, I need to figure out what ratio I'm going to use. I'm going to scroll back up so we can see the acronyms at the top. So if I'm looking for angle A, I'm given two sides in this case, the hypotenuse and the adjacent. Those are the only two sides I'm given in terms of information. I can label the opposite, but there's no information there that I can use. So I'm going to need to use a ratio that has the A and the H. In this case, the only one for that is cosine. So that means cosine A equals adjacent over hypotenuse. That's my ratio that I'm going to be using. And again, the ratio, I'm just getting this formula from the first page of the note. So I'm going to fill in what information I have. So cosine A, because I don't know my angle yet. Remember, A is the angle. Adjacent, I do know. I know that's 15 meters or centimeters. Sorry, if you see on your page, make sure you correct that to centimeters. And I know the hypotenuse is 17 centimeters. What I can do now, I can simplify this. So I can simplify it as 15 divided by 17 if I want. So I get cosine A is equal to 0.882. Again, you could do this, or the inverse, what we do next, without doing the division first. So I mean inverse, so a cosine -1, 0.882. Right, so I could do the same thing straight from here. So I could go right from here and do a is equal to cosine -1 of 15 over 17 and still get the same answer. It may vary slightly because I've rounded this fraction, but again, you should get the same answer. So if I do inverse or cosine -1 of 0.882, again, remember you have to do the shift or second function and then cosine. You should get 28.12 degrees. And if I were to do it the other way with the fraction, so cosine -1 of 15 divided by 17, I get 28.07. So again, you see it's slightly off, but it's still roughly the same idea. It's just because we didn't round the second one. And those are our angles. Again, it's the same angle. It's just two different ways of solving it. If you're not comfortable with using a calculator, I would say just figure out the division first and then use that decimal number with the cosine -1 rather than trying to work this out over here. But again, that's it for today, looking at the sine ratio and the cosine ratio and looking at solving for an angle and solving for a side length. Solving for an angle is always going to be the same steps as we can see here. You plug the information in, you do the division, and then you do the inverse ratio. That's always going to be the same for solving an angle. The only difference will be what ratio you use. For finding a side length, there are the two methods. I'll scroll back up. The two different ways. The missing piece on the top, as we can see over here, the missing piece on the top, you bring the bottom number up and you multiply. Or if the missing piece is on the bottom, you switch these two and divide. So those are the two methods for finding a side length.